Hello, everyone. Exactly, you heard it. Indeed, this webinar is recorded. Welcome, everyone, to today's webinar organized by the DALI Alliance, TALQ Consortium, and Zhaga Consortium. I'm Valentina Ferrara from the Zhaga Consortium, and I'm here today, indeed, to welcome you and to give you first some technical information about today's webinar, and then I leave the floor to our speakers. As you can see, indeed, I wanted just to inform you, as you heard, and the information appear in the next slide, that this webinar is recorded. And as we usually receive this question in the chat, slides will be shared after the webinar. And the question, there will be a moment to ask questions to our speaker at the end of the webinar. So feel free to ask those questions in the chat. So our moderator, indeed the speakers, will be able to read them. Do not wait the end. Feel free indeed to ask your question throughout the webinar. So make sure that indeed we have enough time to read your question and pick it. And now I leave the floor indeed to our speaker of today. Jonathan, the floor is yours.
Thank you very much, Valentina. Hello and good afternoon. I'm Jonathan Catchpole. I will be moderating today's webinar. I'm chair of the Zhaga's Technical Coordination Working Group and vice chair of Zhaga's Book 18 Working Group. I've also been chairing this joint working group between DALI, TALQ and Zhaga, and today I have the pleasure of being joined by representatives of the DALI Alliance and the TALQ Consortia. Scott Wade is the Technical and Certification Manager at DALI, and Sanchis is the chair of TALQ's Certification Working Group. So we have technical representation from all three organizations in this session. Scott, if you can move to the next slide. Before we get started on today's main topic, I just want to make a brief introduction to the three different organizations. The DALI Alliance defines DALI parts, giving requirements for DALI communication and power, develops the official test sequences for use by members, provides product certifications under the DALI 2, D4I and DALI Plus trademarks, and most importantly enables interoperability of drivers, controllers, sensors and other devices. The TALQ Consortium are the creators of the TALQ Smart City protocol, enabling interoperability between central management software and outdoor device networks. They are owners of the two new DALI TALQ Zhaga profiles, which again are the topics of today's webinar. TALQ will also provide certification under the TALQ certification trademarks. And then the Zhaga Consortia creates specifications for all aspects of the lighting industry, focused on enabling interoperable components. We are the owners of Zhaga Book 18, outdoor lighting, mechanical and electrical connectivity platform, and provides product certification under the Zhaga trademarks. Scott, if you can move forward. This joint liaison was created with the purpose of simplifying the process for an end user, whether that is a city, municipality, local authority, or power utility to specify connected and smart street lighting, allowing it to be the platform for smart cities, whilst being upgradable and interoperable between different devices from different manufacturers. The building blocks were already in place. DALI enabling a global standardized way of collecting data, attributes, and defining controls. Zhaga enabling physical connectivity on a standardized platform, and TALQ taking that data, attributes, and control so that it can be visualized on a CMS dashboard. But the unification of that data stream was being left to the end user to define and make possible. This has all changed with the liaison and the creation of the two new TALQ profiles, which have been released last month in the TALQ standard 2.7.0. Now an end user simply needs to list the profiles in their tenders, and they can be assured that the data stream has been unified by means of the three organizations' certification programs, and importantly, TALQ certification of the new profiles. meaning that data, attributes, and controls in DALI drivers and Zhaga D4i sensors can be visible in a CMS platform. This drives many market benefits and should stimulate market expansion. Benefits include, again, creating a truly unified solution, simplifying the tender process, removes ambiguity for both users and manufacturers, provides clear manufacturing requirements for manufacturers, facilitating asset management, safeguarding future readiness, assuring security and resilience through smart asset management, ensuring operational efficiencies, and delivering sustainable benefits. We will now get into the technical details of how this is achieved. And with that said, I'd like to pass over to Scott and DALI's role in this unification.
Thanks, John. I'm the Technical and Certification Manager for the DALI Alliance, and I'm going to go through these topics summarized here. First, just a brief introduction to DALI, the protocol, and the DALI Alliance, and then a look at the types of devices, that the main types of devices, control gear and control devices, plus some of the others. Then we'll answer a couple of questions. What is D4i and what data is available? And then we'll look at how to make that data available outside of the luminaire. So DALI stands for Digital Addressable Lighting Interface, and it's the industry standard protocol, which is a language, for bidirectional digital communications between lighting control devices. It is dedicated to lighting with a rich feature set. The DALI is derived from the open global standard IEC 62386. And DALI 2 is the certification program based on the latest version of the DALI protocol. D4i is an extension of this, making some optional features mandatory, for example, diagnostics data and bus power. And DALI Plus uses a wireless or IP-based carrier to transport the DALI packets. And you can see the three trademark logos that are owned by the DALI Alliance on the right. So these are part of the certification program. The DALI 2, D4i, and DALI Plus are driven by the DALI Alliance, and we provide testing and certification with trademark use, and that helps to ensure interoperability between the products. So a quick look at the types of DALI devices. So these are devices that communicate over the bus. The main ones are the control gear, such as LED drivers or converters to 0 or 1 to 10 volts, and relay units. Control devices split themselves into two categories. So application controllers, they're the brains of the system. They make decisions and send commands to control the lights. And the other type of control devices are the input devices, such as occupancy and light sensors. Several other types of devices are also used in DALI systems. So bus power supplies, they provide power to the DALI bus. The aux power supplies, they provide 24 volts. So that additional power is for use in outdoor luminaires such as streetlights. Repeaters, they allow a DALI bus to be extended. And surge protection devices, SPDs, they're coming soon. And these are especially for outdoor applications. It is also common for products to combine several of the above types. So as an example, you could have an LED driver with a bus power supply and an aux power supply and an SPD all inside the same product, and that can get D4i certification, that type of driver. That would be suitable for outdoor applications usually. So what is D4i? It's an extension to DALI 2. And D4i control gear, the drivers, include a mandatory set of functionality. So there's certain functionalities such as data and bus power supplies, which are optional for DALI 2, but are mandatory for D4i. So D4i control devices include functionality to aid plug and play, and D4i luminaires require 1 to 4 D4i drivers. all of these are intended for intra-luminaire use, where DALI is inside the luminaire. All D4I LED drivers provide luminaire power and energy and diagnostics data. They're available in memory banks. So these enable DALI inside intelligent IoT-ready luminaires. Some D4I drivers can also provide additional lighting functionality such as color control or emergency lighting. You can check the features from the DALI product database on the website. D4I simplifies the addition of sensors and communications devices to luminaires. It also enables plug-and-play interoperability when combined with a connector system, for example, Zhaga Book 18 and 20 or the NEMA and CC 136.41 connectors. So let's look at the data that's available. So D4I LED drivers include the following data, which is all optional for DALI 2. So the luminaire data, that can be used for asset tracking. Examples, and these are just some of the examples, the GTIN, the Global Trade Item Number, that's an electronic barcode, the product name and identification, body color, so that could be the paint color of the pole or the luminaire head, the nominal light output, the light color, the light distribution, and so on. The next part is the power and energy data. That's part 252. And this includes total power and energy, as well as load side power and energy. That's the power and energy delivered to the LEDs. The next data part is diagnostics data. That's part 253. And that provides various measurements and status information, such as the operating time, that could be the control gear or the light source, the supply voltage, failure information, control gear temperature, light source temperature, and a lot more. In addition, all DALI 2 and D4I LED drivers include data such as light output level, lamp failure, fade running status, and lots of other information. So that's data that's available. And that was from the drivers. Now let's look at data from the control devices. And these could be light sensors, occupancy sensors, and these include movement or presence information. And just coming soon, the general purpose sensor. We're in the final stages of adding this to the certification program. And this can provide measurements such as temperature, humidity, CO2 concentration, color, velocity, pole angle and tilt, sound pressure level, and a lot more besides. Multiple sensor types can also be built into the same product. So you could have the light sensor, occupancy sensor, and maybe temperature and humidity. They can all be built into the same product. So that's all part of our certification program. So how is this data made available outside of the luminaire? So we're going to build up a picture of the luminaire just to show you the components and the data flow. So the luminaire itself, so we've got a street light shown here, the outline, and inside you can see a D4I LED driver. And there could be up to 4 of these in a D4I luminaire. And then just a single line is shown to connect to the light source, in this case LEDs. Now the drivers include the integrated bus power supply. That's in all D4I drivers, and many D4I drivers also include the aux power supply, the 24 volt supply, and they provide DALI data. So we've just shown one set of red lines for the data. So this is the intraluminaire DALI bus. So this is inside the luminaire. Of course, you've got power on the same 2 DALI wires, and for the outdoor case, you've got the 24 volts power on a separate wire, so a third wire, which is common with the DALI negatives. So attached to the DALI bus, you could have a D4I sensor, maybe underneath, and above you might have another sensor plus communications device, so one product, one control device providing sensing functionality and wireless communications to the city. So how does this work? So data from these three locations show the drivers, that's one. Secondly, D4I sensor may be underneath, that could be light or movement data, for example. And also the sensor above on the top of the luminaire. So these are sources of information. And this device, number 3, is collecting that information. The data is then transported over the wireless link that's shown here. For example, it could be connecting to the cloud. This part of it is out of scope of our standards. And then a gateway collects this information. And the TALQ protocol is used to provide this data to the CMS, the City or Central Management System. And in the reverse direction, it's also possible to control the luminaire from the CMS. So as well as the data flowing from the luminaire to the gateway to the CMS, the reverse direction is also possible. Now, Pepe from the TALQ Consortium is now going to explain the 2 new TALQ profiles which enable this data.
Okay, let me share my screen. Okay, so thank you, Scott. Well, you just saw how DALI standardizes the information stored in luminaires. And what I will show now is how that information actually reaches the central management software using TALQ. I will walk you through 3 things: how TALQ connects systems, how it standardizes the data, and how this enables interoperability across vendors. And by the end of this talk, you will see clearly how DALI data ends up on the operator's dashboard, which is what we want to achieve. So what is TALQ? TALQ is a standardized interface between the outdoor network gateway and the central management software. And by the way, here gateway refers to the system interface towards the CMS. It is not a specific communication technology like LoRaWAN or others. It sits exactly at that boundary. And communication is bidirectional. Sometimes the gateway sends data, and sometimes the CMS sends commands to the gateway. So for example, the gateway reports discovered devices and collected data to the CMS, while the CMS sends configurations, schedules, or updates to the gateway. Now, everything below the gateway can still be vendor specific. But at this interface, everything is standardized, so the CMS can talk to different vendor systems using one common language. And when we use Zhaga D4I, the data that is stored in the driver becomes available through this interface. So through TALQ certified gateways and CMSs. Now, what does this interface actually cover? TALQ is not limited to street lighting. It spans multiple smart city applications, like, of course, street lighting, but also waste collection, environmental sensing, smart parking, smart traffic, asset management, and more. But the key point is all of these domains use the same set of services. So things like device configuration, data collection, schedule or manual control of the luminaires, group management, and even firmware updates. So regardless of the application, the CMS interacts in a consistent way with all the gateways. And technically, all of this is built on standard web technologies, such as HTTP RESTful APIs with secure TLS communication, which is widely used and well understood by developers. And this means that it is not only standardized for interoperability, but it is also easy to implement for developers. At this point, the key question is, how does the CMS actually understand all this data? And this is where the TALQ data model comes in. Because TALQ defines a common data model, which means that every device is described in the same structured way. So they use the same standardized functions, attributes, and events. So no matter which vendor the data comes from, the CMS understands what it means. For example, things like power consumption, operating hours, or alarms, they are always defined in the same way. And that's what makes interoperability really work, because it's not just exchanging data, it is understanding it consistently. So how do we make sure this interoperability is actually guaranteed? Here is where TALQ profiles become important. The TALQ profiles define exactly what needs to be supported for a given use case. So instead of everything being optional, a profile sets clear requirements. Now, for Zhaga D4i, two specific profiles have been defined, one for luminaires and one for sensors. And the key point is this. In these profiles, all attributes are mandatory. So every compliant system must provide the same data in the same way. And this is also what TALQ certification verifies. Because a TALQ certified system supporting these profiles guarantees that the required data is actually implemented and exposed whenever, of course, it is available in the DALI system. So interoperability is not just defined, it is tested and verified. And what kind of data are we actually talking about within these two new profiles? As we saw in the Scott's presentation, DALI defines several categories of data that are stored in the driver. For instance, we have luminaire data like light output or characteristics of the luminaire, as Scott showed before, energy data like power consumption, or diagnostic data like operating hours or failures. And these are standardized in the DALI parts 251, 252, and 253. But it doesn't stop there. We also have data coming from sensors, what DALI defines as input devices. Things like occupancy sensors, light sensors, or other general purpose sensors such as environmental inputs and so on. Now, the important point is all of this data already exists in the DALI system, and the DALI D4i TALQ Zhaga profiles ensure that this data is exposed through the TALQ interface and made available to the central management software. Let's look at a concrete example. And let me try to zoom the slide a little. Yeah, this is a simple view of a central management software. You can imagine it as a real CMS, but it's just a simplified view. So what you see here is how data from the Zhaga D4i luminaires, so what we have inside the luminaire, appears in the CMS. So the information is stored in the DALI driver, like luminaire data, energy data, and diagnostics, is mapped into TALQ functions and attributes, and then shown here in the user interface. But the important point is not the mapping itself. It is what this means for the operator, because from the operator perspective, all this data is presented in a consistent way. So no matter which vendor the lighting system comes from, it will see the data exactly the same. And this is really the value of interoperability. The system can understand and display data from different networks as if it all came from one. Let's switch on. Now let's look at how this works in practice. Zoom again. You can see here this table with the DALI part, TALQ property, and of course the user interface we just saw. So let's see a small example. So you can see how a value is stored in DALI. For example, the control gear operating time. This is stored in the DALI part 253, memory bank 205, control gear operating time. And this is mapped directly to a TALQ attribute, which, well, but it's not important, but we call this function diagnostic and maintenance data DALI part 5.3 function, and then the attribute is control gear operating time. In practice, this is exchanged as structured data, so in JSON, but always following the same TALQ scheme, so the same TALQ data model. So the CMS doesn't need to know how the data was transported or which vendor system it comes from. It simply reads standardized TALQ attributes, while still understanding what the data represents. And this applies not only to driver data, but also to sensors and other devices. We have here more examples, but I don't think we need to look at it. But that's the key idea. This one-to-one mapping is what makes interoperability actually work in practice. So to summarize, Zhaga D4I standardizes the data inside the luminaire. TALQ standardizes how that data is exposed to the central management software. And together, they deliver interoperability by design. TALQ also ensures vendor-neutral integration, so there is no vendor lock-in. And with standardized profiles, the same data is consistently available across different systems. Now, from a tender perspective, from a city, a utility, or even a consultant, this becomes very simple. If you require Zhaga D4I certification and TALQ certification for these profiles, you ensure a fully interoperable solution. And for those interested, the TALQ tender template is available on the TALQ website. And with that, I'll hand back to Jonathan for questions. Thanks for your attention.
Thank you, Pepe, and thank you, Scott. Very, very interesting stuff. So no questions come in so far. Oh, we've just had one here. Question regarding DALI. So one for you, Scott. Is it possible to update firmware of D4I drivers via a D4I wireless controller, so to enable remote firmware management as light manufacturer through the wireless controller? Is it possible through the DALI standard?
So there is a part of the DALI standard 105 for firmware update. Now, not all drivers support that. It was a part we launched, I think, about a couple of years ago. So you would need to know if the luminaire uses drivers that include part 105. You can check that on our product database. But also the question mentions updating over a wireless controller. So then that wireless controller would also have to support that update feature. So you'd need to check the data sheet for that. It's all possible. You just have to check if the products installed actually support it. Okay.
All right, thank you, Scott. Follow-up question from me then, Scott. So would that also be possible to update a sensor, a Zhaga D4I sensor, in the same way?
Yes, exactly the same. So the control devices and the control gear, the drivers, can include this optional part 105 for firmware update. And it's listed in the product database. Just look for that feature. You can tick the box for part 105 to only find products that do include that.
Okay. We've got another question come in for yourself, Pepe, I think.
Yeah.
As far as I understand, you still need each manufacturer's CMS. So communication via REST API is between the CMS of manufacturer A and the manufacturer B. Is that correct? Or can I directly via HTTP REST API?
Yeah. No, just well, there is a misunderstanding here. The communication is between the gateway, the TALQ gateway, and the TALQ CMS. So when you want to control different ODMs, you need to send messages between the central management software, the CMS, and the gateway through this TALQ API, the RESTful API. I guess that the question is more, can I control other CMSs with one single CMS? You could do it, but you have then to implement in your let's say, in your slave CMS, the gateway role also, so that they can talk each other with the same protocol. I hope it helps.
Okay.
There's another question, I guess.
A few more coming in. So TALQ is built on TCP IP, but there is still no data model for low bandwidth communication between end devices and gateways. For example, LoRaWAN. This prevents full interoperability. Is there any work being considered on this issue?
Well, the thing is that TALQ is network agnostic. So TALQ works with any kind of network you have. In fact, that's why what I try to represent in this slide. And you could have a LoRaWAN network, but you could have also a PLC network. So I'm afraid not, because that's one of the point of TALQ. We are network agnostic. So what we tried with the liaison with DALI and Zhaga is if we use the same data model, that's part of the vendor work to transport the data from the DALI ecosystem to the TALQ ecosystem.
Okay, thank you. Scott, one on DALI. Are there plans for DALI extensions to support requirements for characteristics of solar, e.g. for charge controllers?
Yes, so not just plans, it's actually in progress just now. So we have a subgroup running, which is drafting the specification for this. So that will allow a control gear, a driver, which meets this new part, to have power sources, including battery, PV, and mains, optional power sources. So we've got quite far, but we've still got a bit of work to do. So publication to members may be around the end of this year, but that's just an estimate just now.
Okay, no more. Oh, another question. Another question is if I can have a kind of slave CMS and get rid of another CMS via TALQ directly, connect the controllers of manufacturer B to the CMS of manufacturer A, and never use the CMS of manufacturer B in the first place.
Okay, let me read it again. Oh, well, well, I guess you mean that you could have, let's go back to the slide. Forgive me if I didn't understand correctly the question, but well, first of all, when you say manufacturer A, manufacturer B, actually for TALQ it doesn't matter. So it's a common language, so shouldn't be important. I guess that you mean with one CMS to be able to control or to monitor gateways which are indeed connected to another CMSs. Maybe I'm not sure if I did understood correctly the question. If that's the case, you can, because it was for the OEM. So sorry. So you can, because the one gateway could be connected even to two different CMSs, and then sending a particular data to one CMS and not for the other. So this could work. I'm not sure if I answered your question, Laszlo.
I think there's a follow-up there. The way your slides show it would mean that I buy controllers of manufacturer B and link it directly to manufacturer's A CMS and would not have to use the CMS of manufacturer B at all.
Exactly. That's the whole point. Yes, exactly. So you have no vendor lock-in. Exactly.
Okay, we have a question here. Have you considered including unify OMA data model to complete the full picture of the interoperable solutions? That was something we discussed right at the beginning of the liaison, but I think we felt that between the three organizations, we owned enough of the platform to be able to provide a suitable solution. So Bringing in a fourth organization would have had its own complexities, and we decided not to do that.
Yeah, and also I just would like to give some more technical explanation here. Usify or OMA now, but Usify is defining the data model, which by the way is very similar to the TALQ data model or even to the DALI data model. So maybe they have extended some part of it. But they use a very specific technology to communicate. So as I said, I'm just talking from the technical perspective, but this would be only one network technology, so not all of them. And yeah, from the top perspective, there's something to be discussed. But again, there's something to be discussed, of course.
Yeah, indeed. Another question here. I see in the picture gateways for the DOLN, but there are manufacturers working only with OLC. With 4G, is it necessary to certify that kind of OLC, or is a D4I certified OLC also TALQ ready?
So I guess it's a question for me or for both. I try to.
I think it's for. I think it's for you, Pepe.
Okay. Yeah. Well, if in the D4I OLC you can implement the TALQ protocol, the TALQ communication with the CMS, of course, it will be this OLC would play the gateway role in the TALQ ecosystem, and if I'm not wrong, there are some customers which are implementing it like that. So yeah, it can be done.
Okay. Next question. There is no certification for D4I luminaires, therefore the auxiliary 24 volts on the driver side is optional, and the filling of the memory bank 1 is entirely under the control of the luminaire manufacturer. This situation is essentially based on trust, or is there a need for official weight? So you can Zhaga D4I luminaires.
Yeah, so there are D4I requirements for luminaires, and that includes that the components inside, so the drivers, are already D4I certified, and control devices to be attached have to be D4I certified. As John said, Zhaga then have their additional requirements for the connectors, and they check that the components inside are D4I certified already. So you can check for the Zhaga D4I certification for luminaires. And for outdoor, of course, for Book 18, there's always the 24 volt aux supply inside.
And the requirement, Scott, for filling memory bank 1?
So that is partly optional. So some of the locations are optional, but for D4I luminaires, some of the locations are mandatory. So if you look up the D4I requirements, you see which. So for example, the luminaire G10 or the luminaire company G10 is always written. So you can rely upon that. So check the D4I requirements document. It gives the full details.
Okay. We have another follow-up question from Laszlo Pepe, but I think we should suggest, Laszlo, that you reach out to Pepe directly and start the dialogue directly.
Yeah, I'm happy to answer, but this I answered also this one. This last one was related to the other one, but of course you can reach me.
Okay. One more question just come in. Do you know how many tenders have included references to your TALQ tenders specifications, or whether it has been used as a reference guide in general? Do you see it becoming more and more relevant? I think from the perspective of these two new TALQ profiles, Pepe, they've only just been released, haven't they?
Yeah.
So
yeah, of course.
End of last month that they were available.
Exactly, middle of February. But generally speaking, about TALQ tenders specifications, well, they are more and more, so they are becoming more and more relevant in the tenders. I don't have the whole picture of all the tenders all over the world, but seeing the number of certifications that we are having, the pace is every day faster. So yeah, I would say that it's becoming more and more relevant in the tenders.
And you know, what this group, what the three organizations and the liaison that we formed is to make this unification of the data more relevant to the end user, and the goal is to increase the adoption rate of these. Okay. One more question. So sorry for the in detail question again, just to understand it right. I buy gateway B from manufacturer B, and in the first place it communicates with the CMS of B. Afterwards, I think it's via TALQ to CMS of A. So to begin with, I need both CMS of A and B, right? I can't directly from the box connect hardware from B to A. Because the initial communication with the CMS of A.
Well, it really depends on the implementation, but it could be done. So this is very technical in TALQ, but the first thing that a gateway does when it starts communicating with a CMS is what we call the bootstrap process. And within this bootstrap process, what the gateway does is to send all the devices to the CMS, the type of devices, what we call device classes, and services supported, and so on. And then the CMS sends calendars, sends groups, whatever. So if you have a gateway from a vendor B communicating with a CMS from a vendor B, and then you decided to communicate with another CMS, this gateway could perfectly to start another bootstrap process with another CMS and then start communicating with CMS of a different vendor. So yeah, this is possible. Of course, it depends on the implementation of the gateway, but it can be done with the protocol.
Okay. One last question for Scott. In one project, the luminaire manufacturer don't write anything to memory bank 1. So strictly speaking, the luminaire is not D4I standard.
Well, if it's absolutely nothing, then that's true. It doesn't meet the D4I requirements. But if they have the GTIN written, so that's memory bank 1, the luminaire GTIN, and that can be the luminaire manufacturer GTIN, rather than the GTIN specific to the luminaire. It could be for the luminaire manufacturer. That's sufficient for D4I, but it's also recommended that the combination of the luminaire manufacturer GTIN, luminaire ID, and the ID number, and the luminaire ID string, that they're able to uniquely identify the luminaire, including its brand and model. But if they have written nothing at all, then that doesn't meet D4I requirements.
Very good. Another question, for Pepe, to what extent is a CMS required to use the DALI 251 database? What if it only reads data and does not use the information? The information that is used comes from a CMS database, which must provide in advance. To what extent is the D4I and TALQ compatible?
Well, what we certify in TALQ is that all the mandatory, all what we consider mandatory for TALQ, which is everything mandatory for D4I and some optional attributes, need to be supported by a CMS or by a gateway. So we are certifying the interface between the gateway and the CMS. If the CMS is certified, so is capable to read data from the gateway, but the CMS wants to use this data from an internal database, I mean, we don't certify the CMS. We only certify the CMS interface, the TALQ interface for the CMS. And the last part of your question, to what extent is this D4I and TALQ compatible? I would say 100%, because that's what we wanted to do. So we wanted to make everything which is mandatory in the Zhaga D4I mandatory for TALQ also, for these two new profiles, and even some optional attributes are also mandatory for TALQ, which again, mandatory means that it must be supported by the CMS and by the gateway. Of course, you could have a particular luminaire with no data in this attribute, and this can be sent to the CMS. So mandatory is not required, I would say. But this is a very particular technical data.
Yeah. So if something's optional at the DALI level, it's still mandatory at the TALQ level. But if they've opted not to support that at the DALI level, then it just comes back as a null point, doesn't it?
Exactly. Yeah.
Okay. Well, thank you very much, everyone. Thank you for all your questions. They really got going in the end there. And again, thanks for our speakers, Scott and Pepe. And on that note, we'll close the meeting for today.
Thank you. Bye.
Thank you.
Thank you all.